Hi, we're going to take a quick look at the starter code that was provided that contains a key listener and clock listener. We're going to look first at the key press movement, some things you want to do in regards to keeping whatever you're moving on the screen. We'll take a look at some of the built-in collision for rectangle objects, and then we'll take a look at the clock listener, which will allow you to do some automatic movement. It involves something called a timer and a clock method. And I'll show you a little trick for some automatic movement in between two spots, whether that be horizontally, vertically, or even diagonally. So let's take a look first at the graphics main. This is just going to be something that you're going to run. If you want to change the title to the name of your game, that would be the place to do it. Other than that, you shouldn't change anything here, but this should be the file that you run. In the graphics panel, this is where we're going to have everything that we want to appear on the screen. So right now, there's only a few things that are really a part of the graphics panel class that you see, being rectangle, R, and S. Now, there are a bunch of imports that you don't want to get rid of. You don't want to change anything here. So we have the two rectangles. We have a timer. I added something here that's part of some of my examples for a step value. So that's going to be my interval for how my rectangle is updated, whether I'm updating its X or Y, so that we'll see some movement across the screen. Here we have the constructor where all of these things are instantiated or set up, right? So if we want to change the dimensions of the window, we can edit that here. You can make this bigger if you like by changing the width and height. This focusable true you want to leave, and this add key listener, this line you want to make sure stays here. That registers the key listener with the graphics panel object we're working with. Then we have the creation of the two rectangles. Now these are similar to drawing a rectangle. However, they're a little bit different, and we'll see some in the code that once we create this rectangle 0, 0, 25, 25, we'll be able to directly access its variables. So we'll see r.x, r.y, r.width, r.height. So you can use rectangles to kind of have some variables to work with already set up for you, make your life a little bit easier. You can also make your own drawings and use these X and Y's to be the reference point for moving your drawing, but then update it with some other variable, kind of similar to how I'm going to use this step value. This timer here is going to control your clock method. So when we look at the clock listener, you're going to see the timer is set up to be moving at 25 milliseconds. So if you wanted to go slower or faster, keep in mind it's in milliseconds, so 1,000 milliseconds would be 1 second. So you can adjust this value. Another important piece to that is this t.start. If you don't start the timer, the clock listener doesn't have anything to base its clock listening off of, so you won't have any action performed based on that timer if you don't have start. Okay, so I'm going to start with taking a look at the key listening stuff, but just to show you, the drawings are here, the background is this fill rect here. These rectangles are being drawn based off of the objects that were created, R and S, so you can see width and width can be the same value if it's a rectangle, or we could use height would be okay too. Since they're square, they're the same value, so it doesn't really matter. But just so you recognize that it does have a height property that we can directly access. So that's it's actually a public variable. Okay, and we'll come back to this where we have intersect with S, but you can probably predict what that does. If the R rectangle intersects with S, we're going to have this message appear. Okay, so here's the key listening important things. These methods, these three methods here, key typed, key pressed, and key released, are all required by the key listener interface. Now you don't have to concern yourself too much with what an interface is right now, but just understand that if you were to remove this, then you're going to have some problems. So make sure that you leave that in there. You can use it if you like, but you probably really only need this one key press method. So a key typed would be typing a single key. Key press is going to be an event where you're holding it down. And then key release would be when you let go of a key. So sometimes we use key release to maybe change or set things back when we let go of something. But for right now, we're just going to focus on some basic movement. So key events are objects, right, that are read by the key listener. And one really important method is this get key code. Now, get key codes are really the codes for your keyboard keys. So a key event .vk underscore right is your right arrow. .vk underscore left is your left arrow key. We could use any key on the keyboard, and it's going to be the all caps version of that key. There's some things in there like shift and things like that, or spacebar, which you could use as well. If you really want to find out all the different possible keys you can use, you can search this up. Search virtual keyboard, Java, and you'll find the entire list. Most of them are relatively predictable, but you don't want to do lowercase. Right? It's not going to recognize that. So the constants are all uppercase. Okay. So right now, and probably what you have in your example without any added comments here, is a value that's updating the X for the R. And when I run this, it should listen for me to hit the right key. And if the case is that I hit the right key, it's going to add 8 to my X value. So it should shift it to the right. And the other important thing here is outside of the switch statement, repaint is called so that any changes made to the paint component will be reflected by this repaint call. So this will recall the paint component, and now it will paint the rectangle with X as with the new X as our starting point. So I'm just going to demo that real quickly. Apologize, that has some movement in there that I want to hide for right now. And we'll go right back. Just focus on moving this. So I can move right and I can move left. I haven't programmed any movement for down, but one thing you notice is that I can go off the screen. So one of the first things you want to do when you think about key movement is making sure that your, whatever it is, object, drawing, is not going to just disappear off the edges. So some simple tricks to that, and I'll show you left and right, and you can probably kind of apply that to up and down. We'll add down too, actually, so that you can see collision. So let's go ahead and add in these if statements that I have set up here. So what this says is if the r.x plus the r.width is less than get width, I'm going to add 8. So what that's saying is if my x value is plus my width, right? So the x, y values are your top left corner. If I add the width to that, that's going to give me the right edge. So I want to make sure if the right edge is less than the width, then I can move, right? Once that value is no longer less than the width, that tells it I'm moving off the edge. So it won't allow me to do that anymore. Another thing you could do instead of less than get width, you could use the actual value of the dimension that you put in. What's nice about get width is that if you change the dimension later, you don't have to change this here. The other thing I have is just making sure that I'm not going off the screen to the left. So as long as my x is greater than 0, I'm going to subtract 8. If I hit 0 or I'm less than 0, it's not going to let me do that anymore, preventing me from going off the screen. Now, if I want to add a case that's going to deal with moving down, I can do that. Now, moving down actually increases the y because the x and y, again, is the top left corner. So the y increases as we move down. So if I use r.y plus equals 8, then I'm going to be able to now move down the screen. Now, I don't have the if statement here, but I'll let you figure that one out. So you're going to need to make sure that you're testing the bottom. The bottom would be the r if the y is the top. The bottom would be the y plus the height. So if you're going beyond that, you shouldn't be able to go beyond that anymore. So you want to make sure that you're preventing that. So, but right now, I kind of have it the unprotected way. We'll leave that in. And we should now see, if I run this, here we go, a little delay there, that I won't be allowed to leave the screen. So you can't see it, but I'm holding down the right key. And when I hit the edge, it should stop me. So a little adjustment maybe to that edge where I'm kind of going off just a hair. So I want to be careful about the increment. Maybe I adjust the increment a little bit so that it's matching up just nicely. Maybe 10 is a better choice. I just chose 8 as an example for the time being, but you can see how I'm not going beyond the left there. And I should be able to now move down. If I move down, I could go off the screen. And I don't have any programmed movement for up yet, so I can't even fix that. So right now, this is kind of incomplete, but should help you get started. All right. So the other things I want to talk about are collision, right? So in order to have collision, you can utilize the rectangles intersect method. Now, this is going to tell me if I intersect with another rectangle. There are some other ways that you could use something if you don't have a rectangle object, something called get bound to kind of map to your object that we could talk about in another class session. But this is a really simple, easy way to, if you have a basic rectangle, even if it's invisible in some way, but map to your drawing, that it's just going to detect if they intersect. So now if I run that, I should see that if I move into the space of the red one, that the message appears. Now if I leave, it should go away because the way the paint component is written right now, it only shows if that is currently true. So you could use this as a basis for ending the program. You could kind of turn some other things off here if you wanted to kind of make an intersect the end, or could be a way to maybe reset and start back at the beginning and maybe reset the number of lives your character or rectangle person has. So you've got some options there what you want to do when you have intersect. Okay,